Hello everyone, our lesson for today is all about solving compound interest and different ways of expressing time. If you walk into a bank and open up a savings account, you will earn interest on the money you deposit in the bank. If the interest is calculated once a year, then the interest is called simple interest. If the interest is calculated more than once per year, then it is called compound interest. Consider an investment whose time frame is divided into equal intervals. If an interest is computed after an interval and is being added to the principal and thereafter earns an interest, then the difference between the original principal and the total amount after the whole time frame is called the compound interest. The compound amount, or the accumulated value of the principal, is the sum of the principal and the compound interest. In the context of compound interest, the interest rate per annum or per year is called the nominal rate of interest. The mathematical formula for calculating compound interest depends on several factors. These factors include the amount of money deposited, called the principal, the annual interest rate in decimal form, the number of times the money is compounded per year, and the number of years the amount or the money is left in the bank. These factors lead to the formula FV is equals to P times 1 plus R over N raised to the power of NT, or the future value of the interest or the deposit. P is the principal or amount of money deposited. R is the annual interest rate in decimal form, N in number of times compounded per year, and T in means or for the time in years. To solve compound interest problems, we need to take the given information and plug the information into the compound interest formula and solve for the missing variable, like the future value or FV. The method used to solve the problem will depend on what we are going to find. If we are solving for the time or t, then we will need to use logarithm because the compound interest formula is an exponential equation, and solving exponential equations with different bases requires the use of logarithm. Now let's take a look at this example. If you deposit 4,000 pesos into an account paying 6% annual interest compounded quarterly, how much money will be in the account after 5 years? So here's how we're going to solve the problem. So it is very important that you have to take note the given in the problem. So in this case, the given are the P or the principal is 4,000, R or the rate in decimal form, which is 0.06, and the N is equals to 4, and then T is 5 years. So if we are going to plug in the formula, FV is equals to 4,000, which is P, times 1 plus 0.06, which is the rate, divided by 4, which is N, and then raised to the power of 4 times 5. So FV is equals to 4,000 times 1. So you have to divide first 0.06 by 4 to get the answer, which is 0.05, 0.015 raised to the power of 4 times 5, which is equal to 20. And then 4,000 times, you have to get the 1.015 raised to the power of 20, which will give you 1.346855007. So the final future value will be 5,387.42. So when computing for the compound interest, you have to use the order or operations to simplify the problem. If the problem has decimals, keep as many decimals as possible until the final step. So as you notice, I put the 0.346855007. And then round your final answer to two decimal places like in 0.42. So here, compound interest will be 1387.42, while the total amount in the bank or in the bank account will be 5387.42 at the end of 5 years with an interest rate of 6% per annum. Sometimes the term of investment is not given in years. So the term or time frame given in certain problems may be stated in days or months. In cases where the time is expressed in months, it is easy to express it in years. But when the time or term is given in days, we use a time factor such as the following. Actual time is divided by 360 or 365 days, or approximate time divided by 360 or 365 days. Take note that the banker's rule or ordinary simple interest is applied whenever a given problem does not specify the time factor to be used. For the actual time, we are using the Gregorian calendar. For easy identification of the number of days in a month, you can make use of your knuckles. So as what you can see in the figure on your screen, if the month is located in your bumps, it means that the month has 31 days like January, March, May, July, August, October, and December. So, and if it's in your GOPS, it means that month has 30 days only, like April, June, September, and November. But except for February, that sometimes it has 28 or 29 days, depending on its leap year. So leap year have 366 days instead of the usual 365 days and occur almost every 4 years. It is also a year with an extra day added to keep the calendar synchronized with the astronomical year. So if your calendar has February 25, it means that that year is a leap year. You will know if February is a leap year if it is divisible by 4. So divisible meaning it has no remainder when you are going to divide it by 4, like 2000, 2004, 2008, and so on and so forth. In computing for either the simple and compound interest, time is always required. That's why it's important for us to know the actual and approximate time. For the actual time, we use the Gregorian calendar consists of 12 months with a specific number of days. So here, actual time is the exact number of days in any given month, and while approximate time, it means all months within a year that contains 30 days. Now let's take a look at this example. Find the actual and approximate time from May 1, 1983 to September 15, 1983. So here, 1983 is not a leap year because this is not divisible by 4. And then we have to solve for the actual time. So first, we have to identify the first date, which is May 1, because we will not include it in the computation. So since May has 31 days, we have to deduct May 1. So 31 minus 1 is equals to 30. And then June has 30 days. July has 31 days. August has 31 days also. And then since the last day is September 15, so you must not put September 30 or 30. September 30. You must only put September 15. So after that, you have to add all the number of days, and that would give you 137 days. For the approximate time, since all months must have a 30 days only, so here we have to deduct also 30 minus 1. What that would give you 29. So May 29, and then June until August, you must put 30 days only. And then the last month is September 15. So you have to add all of those days. That would give you 134 days. So that's the end of our lesson for today. As a review, our topic are about compound interest and different ways of